So in this lecture, we're going to feed off the stuff that we learned last time regarding complex numbers. Last time, the only thing that we did with complex numbers was addition, subtraction, division, and multiplication. But if you guys remember that a complex number has a form of z equals a plus ib. So, for example, this is a complex number, x equals negative 5 plus 8i, where negative 5 is your real component and negative 8i is your imaginary component. So you can actually represent every complex number in form of a vector. So where the x-axis is really your a value and your y-axis is your b value. So for example, if we have a complex number that's a plus ib, I can create this vector over here. Okay, and this vector, just like any other vector that we learned about before, is going to have some direction, so it's some angle from the x-axis, and it's also going to have some magnitude. So the way we can figure out the magnitude m, if you guys remember from geometry, is basically a squared plus b squared gives you m squared, right? So really m is the square root of a squared plus b squared. So we're going to learn those two new commands in Matlab and how to deal with complex numbers. So the first thing is, let's go ahead and I'm just going to launch the magnifier here so you can actually see it easily. Okay, so I launched a new M file, and I'm going to start with two complex numbers. Z1 is negative 3 plus 2i. So negative 3 plus 2i means we are going negative on the x-axis and positive on the y-axis. So basically that point is going to fall in the second quadrant. So we're basically going negative here, and then we're going up, so we're basically going to be on the second quadrant. And I'm going to just put a semicolon next to it, and then I'm going to call z2, and that's going to be 5 plus 6i. And I'm going to put a semicolon next to it. So the two new commands that we're actually going to use, one is to actually find the angle from the horizontal, and the second is to find the magnitude. So if I want to find angle of z1, so if I just type a variable name, and again, ang of z1 is just a variable name that I chose, I can say that the command is angle parentheses z1. So that will give me the angle of z1. How far is it away from the horizontal? So if I go ahead and run that by clicking on the play or F5, you'll see that I get an answer here of 2.5536. Okay? Now, is this answer in degrees or radians? Radians. Matlab does everything in radians, so please make sure to remember that the answer that populates is in radians. If your user wants to see it in degrees, you can simply do ang z1 degrees equals to ang z1 multiplied by, in order to convert from radians to degrees, we have to multiply by 180 over pi. Okay, is that clear? And we should expect an angle greater than 90 or less than 90 if we're in the second quadrant. Greater than 90. So I'm going to go ahead and run this, and you should see that the angle that we get on the bottom is 146, which basically satisfied what we just said. Is that clear? Any questions? And you can do the exact same operation for Z2, and you will get the angle of Z2. Okay? Now, if we want to find the magnitude of a complex number, it's also very easy. So if I want to find mag of Z1, all I have to do is type the command abs. And if you remember, abs, if used for a real number, so if I type abs of negative 3, what do you expect the answer to be? Abs is absolute value. So what's the absolute value of negative 3? 3. But the absolute value of a complex number, or the way Matlab is programmed, if we type abs for a complex number, then the result is actually going to be the magnitude of that complex number. So if we type abs of z1 and we hit F5, we'll notice that the magnitude of z1 is 3.6. So I'm just going to go back to the code over here so you guys can see it. Make sure everyone's on the same page. So we just learned how to do angle and magnitude. Is that clear? You can also use the command, so I'm just going to type it here in the command window because I don't want to include it in my code. I can say real of z1. So if I type real of z1, what I'm basically doing is I'm calling for the real component of z1, which is basically the a value. So if you want, you can say, if you want to type it as a command, you can say a of z1 equals real of z1. And if you want b, you type imaginary, imj. Okay, so if we go ahead and run this, the real component is the first part that doesn't have an I, and you'll see that a of z1 is negative 3. Okay, are we good? Is that clear? Any questions? Scroll back up. Okay, I'm going to give you a second to catch up, make sure that your code matches mine. Okay, are we good? Alright, the second thing we're going to learn is how to use or how to create a code that interacts with a user. So I'm going to erase all this, and I'm going to create a code that interacts with a user. What do I mean by that? In some situations, we might need to create a code that accepts an input from the user. For example, if you're creating a code that converts kilogram to pounds, or if you're creating a code that will calculate how many calories you should intake every day based on your weight and height, those are numbers that are going to change depending on what user is running the code, correct? So we're going to have to actually run through this a lot for your design project, because you're going to have to input different numbers, and each one of you is going to have different assumptions. So you're going to have to actually go through all these inputs. So the command is very simple. So we're just going to write a simple code here, and I'm just going to write a comment that says this program accepts mass in kilograms and converts to pounds. Okay, so I'm expecting an input from the user in terms of kilograms. So basically, I'm going to say kg equals input. Okay, and I'm going to parentheses, single quotation, and I'm going to type a sentence or the question that I want the user to read. So I can say enter the mass in kilograms, and then I'm going to close quotation and close parentheses. Now what you want is, although you want to run this code, you want to follow it by a semicolon, because you don't want this code to run and then display the result right after it. So you want to make sure that you put that semicolon so you're not displaying the same result twice. Okay, is that clear? So now basically pounds is equal to kilograms multiplied by 2.2. Okay, and we're not going to put a semicolon next to it because we actually want to solve that. So if we go ahead and run the code, on the bottom you'll see it says enter mass in kilograms. Do you see where the cursor is located? It's located right at the end of the sentence. Okay, so I'm going to show you how to fix that in a second. But just to do a simple analysis, if I go ahead and just type 5 and hit enter, it's going to give me pounds is equal to 11. You see that? Okay, now I'm going to do something over here. What I like to do is I like to get my question, and then I like the cursor to be on a new line, so my number is not right at the end of the sentence. So in order to do that, at the end of your sentence, right before the quotation closes, you put \n. Okay, so if you go ahead and run it now, so \n, you'll see that the cursor now is on the second line, right? And then if I type 10, I'll get 22. Is that clear? Now let's say your code is not as straightforward. and you want to explain to the user what is he seeing, what is that in pounds, okay, what exactly is happening here. Now, of course, this is a simple program, so it's easier to understand. Let's say you have a more complicated program. What you can do is you can use a command called printf, and then single quotations, and you can type whatever sentence you want the user to see right before the answer. So you can say, this is the mass in pounds converted from kilograms. Okay? So if I go ahead and hit F5 now, on the bottom it will tell me enter the mass in kilograms, and I will go ahead and say 10, and then notice how it actually gives me a sentence before it displays that answer. Okay? So now your code is more interactive, and it will create a sequence and explanation of what's happening. So now you can interact with the user, and you can exactly display your result in a specific way. Are we good? Are you using single quotations when you start? Are you using single or double? Okay. Are we good? Because it's running, hit enter. Unless you enter, if you already hit play, just hit enter a couple times and it will clear it, or Control C and it will stop it. Okay? Alright, any questions on this? I want to show you one more thing before. Yes. Because you probably hit play a couple times. If you hit play or hit F5 a couple times, it will actually store that sequence. So look at this. If I hit play, I just hit play 5 times. So over here it tells me enter the mass in kilograms. So if I hit 10, it will run it again. Run it again, because it's still storing in its memory that I clicked 5 times. Okay? Now if that happens, if you went a bit crazy on the F5 and you're running it over and over, right, how do you stop it? Control C and it will stop. Okay? Because sometimes here's what happens for you sometimes. You decide to test the limit of Matlab and you say this. Right? It's a very long array. F5. So I exceeded even the size of Matlab. Nope. There you go. Just wait. Okay? So if that happens, you're not going to sit here and wait. So you just hit Control C. Should kill it. There we go. It kills it. Okay? Are we good? Alright, one more thing I want to show you. Last time we talked about plots. So let's say I have x equals 0 at an increment of 0.1 to 10, semicolon, and I have y equals 3 times exponential of 0.2 x. And remember, you always want to follow the semicolon so it's not spitting up all these numbers. And I'm going to say z equals to 0.5 times sine of 3x. Okay? So last time we learned how to plot things. So I can say plot x, comma y, comma x, comma z. We learned how to do that. This is nothing new. And if I go ahead and run this, I should get a chart that represents both of these both of these figures, both of these values. Okay. Now we also learned how to differentiate which one is which. How do we know that y is the blue and green is the z? Now we learned also how to use legend. Remember that? Remember how we use legend? Okay. If not, please review the older videos. We talk about legend and how to create legends. Okay. Now, what I'm going to show you today is what happens if y is distance and z is velocity. So you cannot plot those on the same figure, because what happens is if you plot them on the same figure, then you're going to have different units and it's not going to be correct. So the way you can separate them is I can say figure plot x comma y. That's going to be my first figure, and I can of course do the title, right? And we talked about this before. This is nothing new. You can do X label and Y label and so on. But also, if I want for my second figure, all I have to do is just type figure one more time. Okay, and then now I'm going to say plot X comma Z. And I can put a title here as well. Okay, so now I have two figures, two plots. That's why they're plotted separately. And if I go ahead and hit F5, you'll see that I actually get two separate figures. Okay, you see that? The first one is the Y, the second one is the Z. I get two separate figures. Okay, is that clear? Any questions? Okay, in some scenarios, instead of having them as two separate figures, you want them to populate as just one pop-up, but two figures on that pop-up. So then what you can do, you can say subplot 2, 1, and what we're basically doing is we're specifying how many charts do we want. So basically we want two rows, we want one column, and this first plot is going to be the first one. And then I'm going to do, I'm erasing all this, subplot 2, 1, 2, because this is my second chart. I'm going to say plot x, z. So now if I go ahead and try to solve this, or if I try to run this, you'll see that I'll just get one pop-up with both of them on the same pop-up. And you can put separate titles for them. You can put separate X labels, separate Y labels, because they are still separate figures. Okay, are we good? Is that clear? Okay, one more thing that I want to show you. Does everyone have this before I move on? Okay, silence. One more thing I want to show you is last time when we did plot x, y, x, z, we could not really control the colors, how they populate, and all these things, right? But now what I can show you is I can say plot x, y, and I want those to be populated with O's, right? We learned that last time, how to look those symbols up, right? X, y, apostrophe, and then I can put asterisks, or I can put dots, I can put B for blue, G for green, R for red, all these things. But now I can say hold on, plot x, z, I'm going to say asterisk over there. Okay, so now I have my Y being in O's and my Z's being in stars, and I'm going to say hold off. Basically, I'm done. These are the only two things I want to put over each other. So I'm still populating as one figure instead of the example that we just learned a second ago, which are two separate figures. But now I can control how they look instead of just a straight line that's blue and green. And if you go ahead and run this, okay, and you see the difference between the two. I probably have too many increments here, So maybe instead of 0.1, I'm going to do like 0.5, and you can see the difference between the two. Is that clear? Any questions? Yes. Any questions? Okay, so this wraps up chapter 3.